Hello, my name is Ivan from Midas IT, and today I'll make a quick demonstration for you on how to use the section property calculator in order to generate or import any section into Midas Civil. To get to that tool, we go into the Tools tab and then click on Section Property Calculator. Here is the interface for the section generation, and first we're prompted to choose our unit system. So I'll go for kilonewtons and meters in this case and click OK. In the section property calculator, there are two main ways of generating our geometry, manually or imported. Let's start with the manual with the manual definition of the section geometry. To do that, we can first do points by coordinate and then draw different shapes using those points, or we can simply use the grid. In this case, I'll set up a grid of 1 centimeter spacing and 150 wide by 50 tall. Click OK and then go to Show Grid and Snap on Grid. Finally, press on Zoom Fit so that we see our full space of the grid. To start with the section itself, there are different shapes that we can generate. All those can be found into Model, Curve, Create, or we can use the quick links on the left. I'll first start with a rectangular shape for the deck. So click on point 1. At the bottom you can see the coordinates of the cursor, so you can use those to get an idea of where you're defining your section. And I'll simply start from the top left corner and make the section 200 deep, so that is y coordinate 0.3. Once done with the deck, we need to also define our eye section, so for that I'll use the line elements. Again, simply defining by 2 points, the line is generated for us. Let's say our eye section will be 400 wide, so that is minus 200 to plus 200 coordinate. You may notice that I made it slightly above the bottom. That is because later I will assign width and this distance will be covered. The same goes for the top flange. Again, from minus 200 to plus 200. And finally we need the web, so that is from 0 to 0 x coordinate. You can see that quickly and easily our section has been drawn. Now, in order to quickly demonstrate the import as well, I will now start a new file and simply import this directly from a DXF. Again, choose the unit system that we're going to use, click OK, and then go for File, Import, AutoCAD DXF. Here we select the file of our section, click Open, OK, and you can see the section is directly imported for us. That is in case we want to use some complex sections where some CAD software might be more convenient to generate the section. Now that we have the section, to finalize the geometry we need to assign some width to the I-beam lines. So to do that we can go into Model, Curve, Change Width, or we can find the same function on the left. Select the width that we want, say 2 centimeters. Select the lines that we want to work with, that is the I-beam, and click Apply, and you can see that our geometry has been defined. Now we need to define some materials for that section. For this we go into Model, Material, and we get our materials list. Click on Add and define our materials one by one. The first one, for example, will be steel. Select the modulus of elasticity, Poisson ratio, and density. Click Apply. You can see the steel has been generated, so now we need the reinforced concrete, modulus of elasticity, the Poisson ratio, and the density. OK, and you can see our two materials have been defined. The next step is to generate our composite section. For this we go into Model, Section, Composite Section, Generate. Here we specify a name for it, number of parts, 2, and a base material. Click Apply, and our section has been generated. Now we need to assign some parts to that section, so we go again into Model, Section, Composite Section, Add Part. Here we choose the part that we are introducing, a name for it, say I-beam. We will include it using line elements, and it will be a material of steel. So select our I section, exclude the slab, holding Control, and click Apply, and then assign part 2, which will be the deck using the plane type and the reinforced concrete material. Select our deck and click Apply. With this, our section has been fully generated and defined. So finally we need to calculate the properties and export it back into Excel. To get the properties of the section, we go into the properties and then calculate composite property. Here we specify a mesh. The smaller mesh we use, the slight increase in the accuracy we'll have, and for this example I would simply use 0.1. Also, we need to select a part of the section that we want to calculate. So in this case I would simply click on the deck, click Apply, and our section properties are calculated. Finally, as I said, we need to export that in order to use it in Midas Civil. For that we click on Model, Section, Composite Section, Export. Here we have to select our section or part of it, and then select the file that we want to use. In this case I will overwrite this demo.sec section file and save on top of it. Click Apply, and our section has been exported. To use the section, we go back into Midas Civil, we go into the Properties tab, Section Properties, add a section, Composite type section, and here we have to choose the Composite General. Then at the bottom we can select Import from SPC, which will prompt us to choose the file that we want to use. Select the demo.section file and click Open. Choose the section from the section list, and you can see our full section has been imported. On the left there is a geometry representation, and here on the right we have the full properties. Of course we can look at part 1, part 2, or the total part. Click Apply. Forgive me, forgot to put a name. We specify a name for our section, say Composite I-beam, click OK, and you can see the section has been assigned directly to the beam which I had pre-generated in the model. You can see the full section is in, and we can use that for analysis and design of our structures. That is it for now. I hope you'll find this useful. In case you have any other inquiries, please don't hesitate to contact any of our teams. Have a nice day.